Welcome to the Hypnos Sleep Channel. Tonight, Hypnos, the ancient Greek god of sleep, will guide us gently through the real dark behind classic science fiction, from imagined doorways and impossible voyages into the older, stranger astronomy that waits beyond them. There is a kind of story that has always used the stars as a doorway, a way of pointing a camera at the real, vast dark overhead and saying, "Gently look." Tonight, we will walk through that doorway together. We will begin with the fiction, the ships, the wormholes, the singularities, the soft, familiar shapes of a story told for nearly 60 years. And then quietly we will step past the fiction into the real universe that inspired it. A universe far stranger and far older than any story could invent. Before we begin, one simple fact to hold on to for the rest of this journey. Light is not instant. It travels very fast, but not infinitely fast, which means every time you look up at anything, you are not seeing it as it is. You are seeing it as it was. Let that settle for a moment, and then let's begin. In the story, starships cross the galaxy by folding space itself around them. Warp drive, bending the road, so the ship never truly needs to break any law of physics, it only needs to change the shape of the space it travels through. It's a beautiful idea, because the real universe has a rule that nothing with mass can travel faster than light. Not starships, not people, not even, in the story's own logic, a ship at ordinary impulse power. So warp drive imagines a loophole not going faster than light, but moving the destination closer. Now, let's step through the doorway into the real number behind that idea. Light in real, unscripted space travels at 299,792 kilometers every single second. From our sun to the Earth, that light takes about 8 minutes to arrive, which means every sunrise you have ever seen is 8 minutes out of date. From the very nearest star beyond our own, a small, quiet red star called Proxima Centauri light takes 4.24 years to reach us. No warp drive exists to close that gap, not really. At our fastest real spacecraft, reaching Proxima Centauri would take tens of thousands of years. Here is a scale to feel it by. If the sun were the size of a basketball held in your hands, the Earth at that scale would be a small, single bead rolling gently nearly 30 meters away. And Proxima Centauri, the next nearest basketball, would be resting over 6,000 kilometers from where you stand. The fiction gave its ships a way to close that distance in days. The real universe simply does not. And there is something restful in that honesty. The universe is not cruel for being so vast. It is only vast the way a night sky is only quiet. Near a small, distant space station orbiting a planet called Bajor, the story places a wormhole, a stable opening found, not built, connecting one edge of the galaxy to the other, 70,000 light-years away in a single, shimmering step. Ships that would otherwise need a human lifetime and more to cross that gap simply glide through and arrive changed by nothing but the journey's meaning. It's one of the story's gentlest ideas, a door, waiting quietly in the dark for someone ready to walk through it. Now, let's step past the fiction into the real physics that inspired it. In the real universe, there is a mathematical possibility called an Einstein-Rosen bridge, what most people simply call a wormhole. The equations come from Einstein's own theory of gravity, general relativity, which describes gravity not as a force reaching out, but as the curving of space and time itself. Mass bends the fabric. It sits in the way a heavy stone bends a soft, stretched sheet. And under the right mathematical conditions, that bent fabric could, in theory, fold enough to connect two very distant points through a shortcut. No one has ever observed a real wormhole. No one knows if they could stay open long enough for anything to pass through. It remains one of the universe's quiet, open questions. Here is a scale to feel it by. 70,000 light-years, the distance the story's wormhole crosses in an instant, is roughly the width of our entire galaxy. To walk that distance at an ordinary walking pace without any shortcut at all would take longer than humanity has existed. The fiction imagines a door already built waiting for us. The real universe only offers the possibility that somewhere, someday, a door like that might be found. And maybe that's enough to rest on tonight. Not the certainty of a shortcut. Only the quiet, mathematical permission to imagine one. In the story, ships often drift through nebulae, vast, glowing clouds where sensors fail, where ships can hide, where the ordinary rules of a voyage seem to soften and blur. The Mutara Nebula. The Badlands, clouds thick enough to swallow a starship whole and quiet enough to feel, in the story, almost sacred. Now let's step past the fiction into the real clouds that inspired them. A nebula, in real astronomy, is simply a vast cloud of gas and dust drifting between the stars. But inside, many of them, something quiet and extraordinary is happening. Gravity patiently pulls that gas and dust together denser and denser until, deep inside the cloud, the pressure and heat grow enough to ignite, and a new star is born. The real Orion Nebula, visible faintly to the naked eye on a clear night, is one such nursery over 1,300 light-years away, and inside it, young stars are still forming even now. The light reaching your eyes tonight from that nebula left it over 13 centuries ago. Here is a scale to feel it by. The Orion Nebula spans roughly 24 light-years across, which means light itself would need 24 years just to cross from one edge to the other. The story's ships pass through their fictional nebulae in moments. The real clouds take millions of years to finish what they start. Every star above you tonight, including our own sun, was born inside a cloud like this one, which makes the cloud not a hiding place, but a cradle. Rest in that thought for a moment. You are made of the same quiet, patient material as every star that has ever formed. In the story, a starship's warp core sometimes bends space using a contained singularity, a tiny, controlled piece of collapsed matter held carefully at the heart of the engine. And elsewhere in the story, a place called the Nexus offers a doorway outside of time itself, found fittingly near the edge of a black hole. The fiction treats singularities as both power source and passage. Now, let's step past the fiction into what a black hole really is. A black hole in real astronomy forms when a massive star exhausts its fuel and collapses under its own gravity, folding in on itself until its mass occupies almost no space at all. Gravity, at that point, becomes so strong that nothing, not light, not matter, not even time as we ordinarily experience it, can escape past a certain boundary. That boundary has a name: the event horizon. Past it is not empty space. It is a region where space-time itself has curved so completely that every direction quietly leads inward. And close to that boundary, something else happens, something the story's nexus only hints at. Time itself begins to slow. To someone watching from a safe distance, a clock falling toward a black hole would appear to tick more and more, slowly approaching, but never quite reaching the horizon. This is not fiction. This is a measured, confirmed consequence of gravity bending time. Here is a scale to feel it by. Our own sun, if it were somehow compressed into a black hole, would need to be crushed into a sphere only about 6 kilometers across. The nearest known black hole to Earth sits roughly 1,560 light-years away, utterly silent, utterly dark, and utterly real. The fiction gave its ships a way to survive that darkness, rest for a moment in the real one. Not with fear, only with the quiet, humbling knowledge that somewhere out there, space-time itself is curved so deeply that even light loses its way home. The story's warp drive bends space in front of a ship and lets space behind it relax. It's often treated as a clever engineering trick, but underneath that trick is a real, quiet truth about how the universe works. Gravity in the real universe is not a force reaching out to pull one object toward another. It is the shape of space-time itself. Every object with mass rests inside the universe the way a heavy stone rests on a soft, stretched sheet, bending the sheet around it. And anything nearby doesn't get pulled so much as it simply rolls gently down the curve that the mass has created. Earth does not orbit the sun because something reaches out and grabs it. Earth orbits the sun because the sun has curved the space around it, and Earth is simply following the straightest possible path through a curved world. This is the real idea that the story's warp drive borrows and stretches and makes fictional. If mass can curve space, then perhaps in some far future something could learn to curve it deliberately. No one has ever built a warp bubble, but the mathematics describing how space-time bends is not fiction at all. Here is a scale to feel it by. Even our own small planet curves the space around it just slightly enough that clocks on satellites high above Earth run very faintly faster than clocks on the ground. A tiny curve measured and real. Multiply that curve by the mass of a star, and space bends enough to hold entire solar systems in orbit for billions of years. Rest for a moment in that shape. You are not floating in empty space tonight. You are resting gently in a curve. The story's federation spans a small corner of a single galaxy, the Milky Way. Even at warp speed, its ships rarely reach the galaxy's edge. And beyond that, the story mostly stays quiet about other galaxies, entirely vast islands of stars far beyond even a warp ship's reach. Now let's step past the fiction into the real scale of our galactic neighborhood. The Milky Way, our home galaxy, contains somewhere between 100 billion and 400 billion stars. It is so large that light itself takes about 100,000 years to cross it from one edge to the other. And our galaxy is not alone. The nearest large galaxy to our own Andromeda sits roughly 2.5 million light-years away, which means the light entering your eyes tonight, if you looked toward Andromeda, left that galaxy 2.5 million years ago, before humans as we are now existed at all. Here is a scale to feel it by. If our entire Milky Way galaxy were shrunk down to the size of a dinner plate, Andromeda at that same scale would be another dinner plate resting about 1.5 meters away. Two enormous islands of stars quietly drifting toward each other across that gap destined billions of years from now to merge. Slowly, gently, the way two clouds drift together in a still sky. The story's ships never make that crossing, but you already have tonight simply by looking up. At the heart of the story's own galaxy, its ships rarely travel a region called simply the galactic core, dense, dangerous, mostly left unexplored. The fiction is right to treat it with caution, because at the very center of nearly every galaxy including our own something enormous and almost entirely silent waits, a supermassive black hole. At the heart of the Milky Way sits one named quietly Sagittarius, a star, with a mass over 4 million times that of our own Sun, all of it compressed into a region smaller than the orbit of Mercury. It does not roar, it does not blaze. It is mostly simply dark, revealed only by the stars that orbit it, swinging faithfully through their long, silent paths, the way a hand traces the edge of something it cannot see directly. Here is a scale to feel it by. 26,000 light-years separate our small solar system from that quiet, massive center. Light leaving it now would take 26,000 years to reach us. We are safe, out here in a quiet outer arm of the galaxy, circling a very ordinary star at a very comfortable distance from something almost unimaginably powerful. Rest for a moment in that comfortable distance. You are exactly where you need to be. The story spans centuries, a rich, layered history stretching from first contact to a federation grown old and wise. It feels, watching it, like a very long time. Now, let's step past the fiction into real, deep time. The universe itself is approximately 13.8 billion years old. Our own sun and solar system formed about 4.6 billion years ago, roughly a third of the universe's entire age. Life on Earth began not long after in the planet's own patient, geological terms, but complex life creatures, forests, anything resembling a story only in the last few 100 million years. And everything the story itself covers every century of its fictional federation amounts to less than a single flicker against that deep, slow backdrop. Here is a scale to feel it by. If the entire history of the universe were compressed into one single calendar year, the Milky Way galaxy would form sometime in March. Our Sun and Earth wouldn't appear until early September. And every moment of recorded human history, every book, every story, every fictional voyage ever imagined would occupy only the last few seconds before midnight on December 31st. Rest for a moment in how brief and how precious that makes this particular quiet moment. Throughout the story, its characters gaze out of viewports at stars that feel immediate presence simply there. It's a comforting illusion, one every night sky quietly offers us too. But here, gently, is the doorway's final, real truth. Because light takes time to travel, looking into space is not looking at the present. It is looking into the past. The sunlight warming your memory of the last clear day left the sun 8 minutes before you felt it. Starlight overhead tonight may have left its star years, centuries, or millions of years before it reached you. Some of the faint points of light in any night sky may not even exist anymore, their light still quietly arriving long after its source has changed or dimmed or gone. A whole sky made of gentle, arriving history. Here is a scale to feel it by. Every time you have ever looked up at any star, you have been in a very real, very literal way, a time traveler. Not moving forward or backward through your own life, but receiving quietly messages sent long, long before you were born. There is nothing to fear in that, only something to feel gently settle over you. You are not simply under the stars tonight. you are inside their history. We began this journey with a story. Ships bending space doors, opening between distant stars, nebulae hiding secrets, singularities powering engines, and a federation spanning centuries across a single small corner of one ordinary galaxy. And gently, chapter by chapter, we stepped past that story into light that takes 8 minutes to reach us from our own sun, into a nearest star 4.24 years away, into wormholes that remain honestly a mathematical hope and not yet a certainty, into nebulae that spend millions of patient years building the stars we now quietly rest beneath, into black holes where space curves so deeply that even light cannot find its way back out, into a galaxy so vast that crossing it at the speed of light itself would take 100,000 years, into a neighboring galaxy whose light left it 2.5 million years before you were born, into a universe 13.8 billion years old, where all of recorded history fits inside the final seconds of a single calendar year, and into the simple, quiet truth that every act of looking up is also an act of looking back. The story gave us ships to make that vastness feel survivable. The real universe gives us something else. Simply the honest, humbling scale of how small, how brief, and how fortunate a single quiet moment looking upward truly is. Before the doorway closes, it is worth lingering with the real science a little longer, because each fictional image works best when it leads us back to something measurable, patient, and true. A faster-than-light story begins with distance, but real astronomy begins with delay. Nothing in the night sky arrives instantly. Every photon is a traveler, and every traveler carries an age. The moon is only a little over 1 light second away, close enough to feel familiar. Yet, even there, the universe asks for patience. The sun is 8 light minutes away, and the nearest stars require years. That delay is not a flaw in the universe. It is part of its quiet texture. Space is not only wide, it is also historical. It turns seeing into remembering, and remembering into a kind of astronomy. This is why fictional shortcuts feel so tender. A warp field, a wormhole, or a folded road is not only a machine, it is a wish to bring the unreachable close enough to greet. In real relativity, the speed of light is not simply a traffic limit. It is woven into causality itself, the order in which events can speak to one another across space and time. If a signal could outrun light in the ordinary way, cause and effect would begin to blur. Some observers could describe the message as arriving before it was sent, and the calm architecture of time would lose its shape. So the real universe protects its sequence with a boundary. The boundary can feel severe, but it also gives the cosmos a kind of grammar. Events have before and after. Light carries news at the fastest lawful speed. A wormhole changes the dream because it does not ask a traveler to sprint through ordinary space. It imagines the map itself changing shape, with 2 distant regions touching through a hidden passage. The difficulty is that equations can permit delicate structures that nature may never build. Mathematics can describe a bridge, while physics still asks what material could hold it open, and what would happen at the mouth. Some versions require exotic negative energy, a strange ingredient not available in ordinary clouds, planets, stars, or machines. Without it, the bridge may pinch closed before anything could pass through. Even so, the idea remains beautiful because it comes from the same theory that explains real black holes, real gravitational waves, real bending of starlight, and real clocks ticking at different rates. Nebulae offer a different kind of truth. They are not gateways. They are workshops. They do not shorten distance. They lengthen time, taking millions of years to gather dust, collapse gas, and kindle stars. Inside a cold molecular cloud, the beginning of a star can be hidden from visible light. Dust wraps the young object like a curtain, while infrared telescopes look through the veil and find warm, newborn centers. A star begins when gravity wins a long, quiet argument against pressure. The cloud contracts, the center heats, and eventually hydrogen nuclei begin the fusion that will shine for millions or billions of years. That process is not gentle in its physics, but from far away it can look almost restful. Blue young stars, red glowing hydrogen, and dark dust lanes compose a cradle large enough to make years feel small. Black holes are born from another ending. A massive star spends its life balancing gravity against the outward pressure of fusion, and when that fuel is gone, the balance can fail with breathtaking speed. The collapse is not simply matter falling inward, it is space-time itself changing its geometry. Once an event horizon forms, the paths that light can take all lead inward, the way downhill paths lead to a valley. The singularity at the center is not a place we understand with ordinary confidence. It marks the edge of our current theories, where general relativity points toward infinities and quantum physics has not yet given a complete answer. That uncertainty is not a weakness in science. It is one of science's honest doors. A black hole tells us where our maps work beautifully, and where the next, deeper map is still waiting. Around black holes, time behaves exactly as relativity says it should. Strong gravity changes the rate at which clocks tick, not as a metaphor, but as a real physical effect measured in satellites, laboratories, and astronomical systems. The same principle that matters near an event horizon also matters gently near Earth. Navigation satellites must account for relativity because tiny differences in time become real differences in position. So the story's most dramatic gravity has a quiet, everyday echo. Every phone map, every satellite correction, every precise orbit carries a small confirmation that space-time is flexible, curved, and real. The Milky Way gives scale another shape. It is not a single object in the simple sense, but a city of stars, gas, dust, dark matter, stellar remnants, and long spiral arms turning around a hidden center. Our sun is not near the center. It lives in a calmer outer region, moving with the galaxy while planets circle it, and while life on one small world looks up through a thin atmosphere. From inside the Milky Way, we cannot step outside to photograph it whole. We infer its shape by measuring stars, gas, dust, radio signals, infrared light, and the motions that reveal the galaxy's structure. Andromeda is easier to see as an island because it is outside us. Its soft oval light is the combined glow of roughly 1 trillion stars, arriving after a journey of about 2.5 million years. When you look toward Andromeda, the distance is not only spatial, It is evolutionary. That light began crossing the darkness before modern humans existed, before cities, before writing, before every familiar landmark of history. The future meeting of the Milky Way and Andromeda will not be a crash like solid objects colliding. Stars are so widely separated that most will pass one another at enormous distances, while gravity reshapes the two galaxies into something new. At the center of our own galaxy, Sagittarius, a star waits as a compact mass of more than 4 million suns. We know it is there because nearby stars orbit an invisible focus with astonishing speed. Those stellar orbits are like a quiet signature written around darkness. Nothing has to shine from the center for gravity to reveal it. The stars trace the shape of what cannot be directly touched. Deep time then gathers all of these scales into one longer breath. Stars are born, live, and die. Galaxies assemble. Elements form in stellar interiors and explosive deaths. Planets grow from leftover dust. The calcium in bone, the oxygen in breath, the iron in blood, and the carbon in every living cell are not separate from astronomy. They are astronomy, cooled and rearranged into a temporary human form. That is why the real dark can feel less empty the longer we look at it. It is not a blank wall beyond the world. It is the older home of the ingredients from which the world was made. Stories help us approach that truth without flinching. They give us ships, stations, doors, engines, and familiar rooms. Science gives us the numbers, the measurements, and the humbling patience underneath. Between them, the mind can rest. The fictional image opens the door, and the real universe waits on the other side, not louder, not faster, but deeper and more generous than the image that led us there. There is comfort in knowing that imagination did not have to invent wonder from nothing. It only had to notice the wonder already present, then build a small lamp to carry into it. A nebula did not need a story to become beautiful. A black hole did not need a name to bend light. A galaxy did not need a camera to turn slowly through billions of years. But a story can teach us where to look. It can make the first glance easier. It can soften the numbers just enough for the heart to receive them. And once the heart has received them, the real universe can do the rest. The distances become quiet instead of frightening. The darkness becomes spacious instead of empty. The old light keeps arriving. So let the final doorway remain open for a while. Let every imagined voyage return to the patient facts beneath it, and let every patient fact keep a little of the wonder that first invited you through. Rest there now. Let the real dark hold you exactly the way it has always held every star, every nebula, every quiet, patient, ancient thing floating gently within it. You are made of the same material. You are allowed the same rest.